We have a great day today. We're going to be talking about this fellow. His name is Leonard Susskind. He's a professor at Stanford University. He allegedly teaches physics. We have a great day today. We're going to be talking about this fellow. His name is Leonard Susskind. Got a little repeat there. Anyways, we're going to be talking about him. And he calls himself or goes by the moniker Lenny. I prefer to think of him as Leo, and turns out that Leo, he's not a very intelligent fellow because he says he knows nothing. And you might say, well, Bill, you're insulting him. Why are you treating him like this? And it's not that I'm insulting him. He's telling you in your face, right, that he doesn't know anything. He doesn't know about light. He doesn't know about gravity. He doesn't know about magnetism, the atom. Certainly can't draw an atom. And the question is, what is he teaching them? I mean, can you imagine going into Stanford University, freshman, and you say, oh, I'm going to be taking a course with Lenny Susskind, Leo Susskind. And it turns out that, he's been teaching for over 50 years. He's 85 years old now. He's been teaching for over 50 years, he says. And the question is, what does he teach? Because he's telling you that he doesn't know anything about light or gravity or any of these things. And can you imagine he starts his class, his presentation, his dissertation, saying, oh, by the way, folks, I don't know anything about light, but I'll be your teacher, your instructor for the next 6 months. My God, must scare the hell out of all freshmen when he does that. Anyways, he's like the blind leading the blind, or maybe he's being pushed by the blind because he got all his information from these other individuals who knew just as much as he did, or he does, right? So, we have a problem with these folks because they're teachers, they're instructors, and they make quite a bit of money, really. They get good salaries. And in the case of Stanford University, it received $2.2 billion from, federal funds or state funds or both, I don't know, government funds. That means you're paying, through your taxes, you're paying these people's salaries and who knows, research, whatever they do. And that's a big problem because it's coming out of your pocket and you're paying for an ignoramus, person who admits, who confesses being an ignoramus. So it's not me that's saying that he's ignorant, he's saying that he's an ignoramus, okay? And we're going to listen to his own words today. It's going to come out of the horse's mouth. I'm not going to put words in his mouth. I'm just going to repeat what he said of himself, okay? Anyways, why did I pick on good old Lenny, good old Leo? Because he started a channel like a month ago, and a YouTube channel. Just like a lot of these folks, they've been doing this lately. Sabine Hassenfelder and Brian Cox, Brian Green, all these people, they started YouTube channels. I guess they don't make enough money from the government, from taxes, right? So they had to, go on their own on YouTube and try to make some money. So what does good old Leo tells us? He says, if you're curious about how the universe truly works, he's going to talk about explanations, right? This channel is for you. Well, I think that's tremendously misleading, and the reason is, mathematician, these people call themselves mathematical physicists. Okay, let's call them mathematical physicists, doesn't matter. Mathematical physics does not explain. There's no explanations in all of mathematical physics, okay? What they have are descriptions, mathematical descriptions. They call them theories. Theories are explanations, and these people are telling you that they can explain when they cannot. What they're doing is describing. They cannot tell you the cause, the mechanisms that Mother Nature uses to do gravity or light or whatever, right? And just in case, here it is. We have it from Donald Simonek, and he's a professor emeritus at Lock Haven University in Pennsylvania. And he says, science doesn't explain. Straightforward, doesn't explain. What does it do? Science describes. What is he talking about? He's not talking about science. He's talking about mathematical physics. Okay, he says postulates models to describe how some parts of the nature behaves. Right. That's all they can do. They cannot tell you what causes gravity. They cannot tell you why, what causes this spoon to fall downwards. Something as simple as that. Kindergarten stuff. And they can't do it. And this is after at least a couple thousand years. We're talking about maybe, 2,500 years since the days of Plato, right? Give me a second here. Remove that. Since the days of Plato, he had this sign on his door of the academy saying, no one ignorant of geometry may enter here. And that's more or less, what these people are still saying to this day. Whoa. Give me a second here. There we go. Anyways, Leo started his own channel, and this is what he's trying to make some money off of, or someone else who's sponsoring him. Someone is trying to make money off of that, aside from the money that you're paying through your taxes to his salary and to Stanford University. Okay. And so I looked at some of the videos that he has there, and I picked the one that interested me the most, which is this one. It's about light, okay? And it says, why light doesn't move. And I said, well, that's got to be interesting if he can show me that light doesn't move, right? And why is that a problem? Well, it's a little bit of a problem because we all know that light moves at 300,000 kilometers per second. And so how can he say that light doesn't move? We seem to have a contradiction there, right? Okay, just looking one of the comments there. Anyways, we have a problem because, we know that light moves. Something is moving in there. And the question is, what do you mean light doesn't move? And so he's going to say that, time, the photon doesn't suffer any time. That's going to be his argument, because the photon doesn't suffer any time, it's not moving. Okay, so we have a problem, because, all we have to do is define what the word motion means. And if the photon meets the criteria of the definition of the word motion, then it moves by definition, pursuant to the definition. That's how simple it is. It's straightforward. It's not a question of opinion. It's not a question of what the photon is thinking or looking at itself, like Leo tells us, that the photon looks at itself and says, oh, I'm not experiencing any motion. What is the definition of motion? We'll know if the photon is moving or not. We just have to follow the definition. Okay, so we do have, he tells us, he says in so many words that he doesn't know what light is, okay? And the question is, how can he say that after so many thousands of years? And especially, since we've known what the mediator of light is for now 28 years. In fact, on the 23rd of February, it's going to be 28 years since humans discovered the mediator of light. And here it is. This is the timeline for the rope model, right? Discovery happened in 23rd of February of 1998. Since then, we presented the model, right? In the book, What is the Electron? I talked about that last week. Presented it in Hong Kong in China, right? And published a paper, an alternative to waves and packets, wave packets, right? Peer-reviewed journal. And it was presented in the St. Andrews University in Scotland. There you have all the dates. And we've had several rational physics conferences, right, throughout these years. You can see them there. Okay, so the model has been presented. Now, if Leo is not keeping track of the scientific literature, well, I can't help him there. Maybe some of these people just talk amongst themselves because they believe that anyone below them, as they see it, right, cannot contribute anything to their understanding of the universe. So they want to talk, but they don't want to listen, right? And what they're really doing is listening to their own echoes, okay? Because, when you talk to people that think exactly like you're not going to have new ideas. You're not going to be challenged in your ideas. A little bit here, maybe some minor differences between them, but if they all subscribe to the same notions, then they're not going to have a model that they can sink their teeth into, and chew, and try to make something of it. And so this is the problem. The problem is that these people talk amongst themselves. They don't go out there, listen to new ideas, and that's why they're only hearing their own echoes. And so it's not surprising that here we are, 21st century, and he says after 50 years, he cannot tell you what light is. That's essentially where we're at. Okay, so what is our proposal? What do we propose for light? Let's start there so that we can later on compare what Lenny is saying, right? Compared to what light is, right? And here it is. This is where we start. We have the transverse wave, electromagnetic wave. Fresnel was essentially the first one who came up with this notion of the transverse wave, trying to explain polarization. And then you could say, well, went through a couple of these other people, but it essentially ended up with Maxwell, and he mathematized it. Okay, so great. What did good old Max come up with? Well, he says, look, it's an electromagnetic wave. It's a transverse wave. And what was he talking about? Well, he wasn't talking about physics. First and foremost, he wasn't talking about physics. Neither were any of those fellows that you see up there. What they were talking about is math. And what they said, look, we have this electromagnetic wave. It's made of two fields, the electric and magnetic field. What is a field? Well, there you see the definition, a value at each point in space. What is each field made of? Those arrows. And those are pictorial representations of vectors. What is a vector? Well, there you see the definition, magnitude and direction. Again, numbers. So what they did was they put this thingy there that has arrows and some little fancy lines, curving lines, right? And this is a pictorial representation of a mathematical concept, of plural in that case, mathematical concept, both vectors and fields, okay? They're not physical objects. Those words do not belong in physics. They belong exclusively to math, okay? And then they put this in motion. You see all these vectors, these fields moving sideways. Very scary stuff, and this is what they teach everybody from high school onwards. Okay, so this is where they start, okay? And what did we do? Well, we went in there and we replaced that nonsense known as the transverse wave. We replaced it with a physical object, okay? It's known as a rope, okay? The electromagnetic rope. As you can see, it has a similar physical configuration, but rope is a physical object, whereas the wave is not, okay? The other thing is that the rope stretches from atom to atom, whereas the electromagnetic wave comes out of an atom and goes off to nowhere one way. The rope is a two-way mechanism. It's a torsion. And right off the bat, we can explain two things. We can explain first the speed of light. Why is light so fast? 300,000 kilometers per second. And it's because it's a torsion. It's not a transverse wave. It's not a longitudinal wave. It's a torsion wave, a 3D torsion wave that torques in situ. The rope just torques in situ. It's already connected at the other end. It doesn't have to travel anywhere, okay? The other thing we can explain with this is why, the little c, 300,000 kilometers per second, why it's a constant. It doesn't go any faster. It doesn't go any slower, at least in our universe, right? And when frequency goes up, wavelength goes down, and vice versa. Well, only a rope can explain that. This is the equation of a rope, and only a rope. It cannot be represented by anything else. For example, you cannot represent this with a chain. Chain has different links, and you cannot reproduce that equation with a chain or any other elongated object. It's got to be a rope-like mechanism, entity, mediator. And you can see why. You have a rope, you torque it more, and you get more links, but each link is shorter. So we have more links, meaning we have higher frequency, and each link, wavelength, right, is shorter, and vice versa. Okay, straightforward. So we can explain the speed right off the bat, and we can explain why it's a constant, why the speed of light is a constant, 300,000 kilometers per second, rounding off, 299, whatever. Okay, so here we see, them in motion, one right next to the other, okay? And you can see the rope just torques in situ, in place, right? And it's a physical object. The mathematical concept you see at the top, moving sideways, that's just scary stuff. You have concepts that are moving, mathematical concepts that are in motion. You got to be in the loony asylum to come up with something like that. Okay, so the rope is made of two threads. Those threads are the ones that construct the atom also. So it's not like the atom is something different than the rope. They're made out of the same threads that, the threads that make up the rope also make up the atom. And we've shown this in the past, so I'm going to go relatively swiftly through it, but here it is. You can see the electric thread, arbitrary name, right? Just to be constant with convention, goes straight through the atom. The electron, the magnetic thread goes around and encapsulates the proton star, okay? And we have all the ropes from every atom in the universe converging upon our atom. What you see there, the blue ones, those are just the threads, again, the electric thread that goes through the center, right? And comes out the other end, and the rope continues to another atom. Meanwhile, you have the magnetic thread that encapsulates the electric threads, right? They form this electron shell or membrane or balloon that encapsulates the proton star, and that is our atom. So the whole universe is interconnected. Why? Because the same threads that construct the atom also construct the ropes, and vice versa. Okay? So it's atom, rope, atom, rope, atom, rope, and made out of the same thread. There's a single thread in the entire universe. Totally different model than what we have in mathematical physics. These folks did not figure it out. Okay? And here we have a comparison of the atoms. Okay? This is what they came up with. They have this planetary model that Niels Bohr and Rutherford came up with. And from there you have these, you can call energy, they call it. It's this wave that is being manufactured by the atom and comes out of the atom. Turns into a ball when it reaches another atom, I guess, when it's detected right at the other end. But meanwhile, it just goes off to nowhere. Whereas our model has a totally different. I mean, what you have is the quantum jump of the atom, which is an expansion and contraction of the electron shell or electron membrane, right? And what it does, by doing so, it torques the rope. And that's how we have the quantum jump merged with the torsion on the rope, why the rope is torquing. And there you see it. You see why it's so fast. It's a torsion, and it goes in both directions, from your eye to my eye, okay? And the entire universe is, every atom in the universe is interconnected. That's what we have. This is the universe. If you had the eyes of God, right, or Atom Man, right, you go into this world of the microscopic world, the subatomic world, and this is more or less what you would see. All atoms in the universe are physically interconnected. And again, we're saying they're physically interconnected. They're not connected by concepts, especially by mathematical concepts, okay? And here you can see just another aspect of this model. Here you have electricity, okay? According to the quantum and classical mechanics, what you have is a little bead called the electron. They call it a charge. Charge is just a number, 1.6 times 10 to the minus 19 coulombs. That's what charge is. And they have these charges just flowing from negative to positive, from negative to positive. And the issue is they never define what negative and positive are in physical terms. What we have is torsion in situ. All atoms are connected to all other atoms, and they torque in situ. What you have is a signal moving along these atoms from one side to the other, and it's not negative to positive, it's clockwise to counterclockwise, okay? On the right side there, you see what happens inside a vacuum chamber. You evacuate it, and what you have is the electrons, in the case of quantum mechanics, moving from cathode to anode, from negative to positive for whatever reason. We don't know why. They just say one is negative, the other is positive, and that's all they know. They've never defined what negative or positive is. And what we're saying is that's not what's happening inside a chamber. What you have is all atoms are merged with each other, and the whole serpentine, as we call it, is torting in situ. Okay, so what you have is a torsion moving along all these atoms. Electricity is not a bunch of flowing charges, whatever those are. It's the in situ torsion of a whole bunch of atoms. The atoms are going nowhere, okay? And that's essentially the model for that, for electricity. How do they explain electricity? Because, magnetism is, they say, well, the magnets, they have all these electrons, these charges, as they call them, and they're spinning in situ, or I guess in situ. I assume that they never explain that in fine detail, but they say they're spinning. Okay, whatever spin is, because they never define spin, it's some kind of angular momentum that doesn't angular momentum nothing. It doesn't move. They have it spinning like a top in situ. Okay, so let's concede. So it spins in situ. The electron is spinning in the magnet where it's at. It's just spinning. How does it attract another magnet from far away? Here you have two magnets, north facing south, right? And the electrons are spinning. Great. We have space in between. How is one magnet attracting or repulsing the other one? By having spinning electrons. Please explain the process. Please explain the mechanism. And they never do. They just say, oh, we discovered that, whenever one magnet attracts the other, we find that the fields and the electrons are spinning around. And you can't use the word field because what's field? Remember, it was a value at each point in space. It's a mathematical concept. You can't use the word field in physics, okay? Because field is a concept, a mathematical concept. You cannot say the field pulls or does this or does that any more than love can do that, or intelligence or data or information, right? So yeah, we have a problem because they never define these words, okay? And they try to get away with nonsense, with some, fancy word salad. That's what it is. It's word salad. Okay, so how do we do magnetism? Very straightforward, okay? We have the threads are swinging around. When they're going clockwise, both sides, what they do is they interact with each other and they pull. And you can turn it 180 degrees, and now you can see why they repulse, because now you have clockwise against counterclockwise, and they push each other away. It's the threads that we cannot see that are swinging in that region they call field. Those are the lines of force that Faraday talked about, okay? We're talking about physical objects. They're known as threads, and they're swinging around. Okay, and again, I'm not going into any detail of this. There's many videos that I have out there, several of them on magnetism, on electricity. I'm just presenting the model in, superficially. Anyways, you're saying, well, Bill, how can you be sure that the rope is what's out there, that light is mediated by a pair of twined threads? And the answer is, it's we can't be sure because we're making an assumption about what the mediator is. But the way we look at it is if it quacks like a duck, talks like a duck, walks like a duck, and poops like a duck, well, it probably is a duck. And so, it's that's how we look at this. We make an assumption, and with that assumption, we can explain all the at least the most fundamental aspects of light and gravity, magnetism, electricity, etc., and the atom, right? Then we think we have a pretty good model there, at least to sink our teeth into. We've got something there, we can take to the bank, so to speak. Okay, so here's a series of things that the rope model can explain. We've got videos on each one of these, These are the things that the rope model can explain. Why the speed of light is so fast, why it's a constant. We can explain, these aspects, frequency, wavelength, amplitude, why light travels in waves, because it's already structurally built like a wave. It's already wavy, right? Entanglement, EPR, because there's no action at a distance. There is something there that we cannot see or touch. That's why entanglement works. And the other thing about entanglement is that, from one end it's clockwise, from the other end it had better be counterclockwise. So whenever they measure, it's not positive and negative, it's clockwise and counterclockwise. Ray reversibility is something you cannot explain in all of quantum mechanics. They never do, they never touch the subject. Light retraces its exact path. The only way you can explain that is if you have the mediator that connects already the two endpoints. Okay, and so we can explain ray reversibility quite easily. Remember, everything's moving in the universe, so under the quantum version, light would never retrace its path, whether it's you're throwing a wave or whether you're throwing a particle one way. By the time it reaches the target and comes back, it's not going to retrace its path because everything in the universe moved. So yeah, you cannot explain ray reversibility in quantum mechanics. Reflection, refraction, we can explain that easily. Photoelectric effect, no problem there as well. On the right side there, charge energy, what is it? We've got a video on that as well. Diffraction, the slit experiment, piece of cake, no biggie. These people are still struggling. They have to put the photon at two places at once. And that's how they explain it. They say the photon essentially is at two places at once. That makes a lot of sense. Yeah. Polarization, we touched upon that the other day. White light travels as a wave and departs and arrives as a particle. Yeah, because at the endpoints where it touches the atom, it's detected as a particle. But in between, you got this rope, which is the wave nature of light, so to speak. And white light seems to be everywhere. You have the cosmic background radiation, because you have all these ropes crisscrossing the universe. That's what these people are detecting, the vibrations of all these ropes in the universe. And they say, oh, it's this cosmic background radiation that came all the way from the Big Bang. No. It didn't come from the Big Bang because the Big Bang never happened. Okay, it's just as simple as that. You have to show that how you create something out of nothing in order to talk about the Big Bang. And they never do. They always start at frame number 2 of the movie. They never go to frame number 1. How did the singularity get there in the first place? And that's when they start using, virtual particles and other magical stuff. And then we can explain the red shift, blue shift, okay, very easily. They have all these explanations on you can call them explanations. They're not explanations because they rely on magic, on irrationality, and therefore they are not explanations. They are not mechanism. But they think that some stars, some galaxies, primarily almost all of them, right? Because they're saying they're receding from the Earth because they are red-shifted. And redshift, if you go to the Doppler effect, you say, well, when it runs away from me, it's redshifted. When it's coming towards me, it's blue shifted. Not true. Not true. There's another explanation for that, another version, and that is that the rope, as you extend it, right, from farther away, it's going to be redshifted because the links become longer, and that's the link that's hitting your eye. So you're getting a longer link here. And the blue one, the ones that's closer by, it's going to be blue shifted. The rope is going to be, wound more. The frequency is going to be higher, and the wavelength, in other words, the link length, is going to be shorter. And so, no, the red shift, blue shift has nothing to do in out there in the universe, right? With how far, well, it does have to do with how far it is, but it doesn't have to do with the fact that it's traveling away from you. We're talking about location. This thing is just farther away than the other one, but it doesn't mean that it's running away from us or coming towards us. So we have Andromeda galaxy. It's coming towards us. It's in this local group, and other galaxies in the local group, they're blue shift. And you say, how do you explain that? And so they have to go through all this rigmarole to try to explain these things, mathematically, right? And they run simulations on their computer to try to explain this because they think it's running away from us. And the farther it is, they say it's running faster away from us. No, 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 no. It's not that the farther away it's running faster. It's just that if it's far away, it's going to be blue shifted. It's close by without any motion whatsoever. It's already going to be red shifted. Okay, so, well, I'll explain more detail some other day, but that's just a superficial explanation for that. Anyways, we can explain, the atom and gravity also, different aspects of the atom and gravity. So what an atom looks like. Schrodinger's equation, again, it's not that you have a little bead and we try to find the location of that bead within a wave function. Is that what they call it? A cloud, no, it is a cloud, but it's it's a ball of yarn. That's what it is. It's a physical object. It's a physical surface that the atom has. And Schrodinger's equation only tells you where the electron, where a point on that electron membrane is. What you're doing is measuring a point on the electron shell, which is expanding, contracting, vibrating, so it's moving around. That's why they say, well, we can more or less tell you where the electron is. Now, it's not an electron bead that is located anywhere. It's that what you're doing is measuring a point on the surface of the electron balloon that's expanding and contracting and vibrating. That's what they're doing. And so Schrodinger's equation is correct, but it's the wrong interpretation that quantum has for it. They think it's a little bead that's going back and forth and moving around. They say, well, we don't know where it's at, because when we can locate its position, we don't know about its momentum. When we know its momentum, we don't know about its position. That's the Heisenberg uncertainty principle, right? And none of that is true. What it is you're measuring the surface of a balloon that's expanding and contracting and vibrating. That's what you're doing. And de Broglie's equation, same thing. Why is it wave? Because it's a wave that's going around. The thread, the magnetic thread, we arbitrarily call it the magnetic thread, is going all around building the electron shell. And it's a wavy entity that goes all around. So that's why it's wavy. Yeah, it's it's going all the magnetic thread is going all around and building the electron shell, the electron membrane, the electron balloon. That's why it's a cloud, right? The wave function, yeah, it's a cloud. Of course, it's what it is. It's a balloon. That's what it is. We can explain ionization, bonding, positive and negative. No, that's clockwise, counterclockwise, right? That's what it is. Mother Nature does not understand positive or negative, which are mathematical concepts. She does understand, clockwise and counterclockwise. That's physics, okay? Orbital energy level, again, it's a balloon that's expanding and contracting. That's why the electron does not fall, negative electron doesn't fall all the way to the positive nucleus, because it's a balloon that's just expanding and contracting within, the region of what they call orbitals or energy levels. Electricity, magnetism, piece of cake, no problem. How the sun works, pretty much we agree with quantum mechanics that there's a thermonuclear reaction inside the sun. Where we differ from the quantum mechanics is that there's no such thing as energy. Energy, again, is a mathematical concept. So the sun doesn't transfer energy to our eyes. No, there's no such monster as energy in physics. Okay, energy is a mathematical term. So what we need to figure out is what is it that the sun is sending us. And again, every atom in the sun is connected to every atom on Earth, including every atom of your eye. And what it's doing is sending signals along the ropes that are connecting every atom in the sun to every atom on Earth. That's how simple it is. Okay, it's very straightforward. It's physics. It's physical interpretations. None of this mathematical nonsense that these people have created, this monster. Gravity, we got the gut and the toe, grand unified theory, theory of everything, principle of equivalence. I've covered that several times. No biggie there. It's very simple. And the main point there is that, what these people never figured out is what weight is. And they have this notion, let me get this out for a second. They have this notion that if God comes in there or, a magician comes in there, moves his magic wand, right? Says abracadabra, makes the sun disappear. We would not notice the gravity for the next 8 minutes, which is what the speed of gravity is alleged to be in the religion of mathematical physics. Says that, it would take 8 minutes for that signal to reach you. And where did they get that? They got this from the fact that nothing can travel faster than light, including gravity. And so they said, well, if nothing can travel faster than light, because that's what special relativity says, that means gravity cannot travel, the influence of gravity cannot travel faster than light. So if we make the sun disappear, it would take 8 minutes for us to notice that the sun is not there, because the gravity would still be coming despite that, the sun is no longer there. And that's like saying, you have your daughter maybe hanging from a rope from you. You're up there in the mountain. She's hanging from a rope, and you cut the rope. And they say it's going to take 8 minutes for the signal to reach her. That's what they're saying. They're saying, if she's hanging from the rope, and you're climbing the mountain, and you cut the rope, she won't fall instantaneously. She won't fall immediately. It'll take, so much time until that signal reaches her and she figures out that, she's falling. No, that's totally irrational. Every atom in the universe is connected to all atoms in the universe, and that means that every atom of the sun is connected to every atom of you and every atom of the earth. So if the sun were to disappear, you would fly off like your daughter would fly off if you cut the rope. She's hanging from you and you're holding onto the rock in the mountain. She would fall instantaneously. And that's how what would happen if you made the sun disappear. Okay. So anyways, continuing here, we explain action at a distance very easily. There is no action at a distance. It's that we cannot see or touch the mediators. We're done. That's all. That was the secret that they had to discover all these years. Mercury's perihelion shift, no biggie. You have little Mercury, and you can more or less simulate this, on your own. Let's see if I can do this. Here you have a ball, and I've got it tied to this. I've got a better one here. Let's see if I can do it with this one. Here you have a little ball, okay? And I'm going to swing it around, okay? This is what's happening. This is how the planets orbit the sun, okay? They're all bound by countless threads, countless ropes, right? Every atom is connected to every atom with ropes. So you have this swinging around, okay? Now imagine if I were to cut that rope where I made my hand disappear. Well, guess what happens? This will fly out immediately, right, out of my hand. But this is the issue. The issue is that how do we explain the perihelion? Well, it's like this. You have a little bead. Imagine trying to have a little guy like this guy, right? And you swing it around, right, very close to your finger compared to, a longer string, right? And if you were swinging it around like this, right? Okay, so there's a difference between Mercury, which is a little bead tied very close to the sun, compared to Jupiter, which is big and far away. So they would swing in a little different way. And that's what we're noticing with the perihelion shift. So that's just an intuitive version of, what's happening with the Mercury's perihelion. I have gone in a little more detail in other videos on that as well. Okay, anyways, let's continue here. Again, we're summarizing here. Galaxy rotation problem, dark matter. You have to explain why the stars on the outside either travel faster or at the same speed as the ones on the inside. The ones on the inside track should be going faster, like Mercury around the sun versus Pluto around the sun, right? And what's the issue there? The issue is that you have to explain why the stars on the outside travel faster or just as fast. And the issue there is very simple. It's that first you had to explain why those stars don't fly out of the galaxy to begin with. I mean, if the galaxy is rotating and you have these stars on the outside, why don't they fly away spontaneously? And they cannot explain that, and I'll tell you why. They cannot explain it because they use the word mass and they use the word gravity. And those are concepts. And we need to figure out what physical object is retaining the star to the center of the galaxy. That's what you need to figure out. And yeah, with a rope, you can figure out why, because all atoms of every star is connected to the atoms of every other star. So the whole galaxy rotates like a carousel. Like, the horses on the carousel and the buggies, they don't fly out of the carousel. Why? Because they're stuck to the carousel. And that's more or less the situation with dark matter. There is no such thing as dark matter, which are particles which weigh tons and tons and are invisible, translucent, et cetera, right? They work from action at a distance. They work through mass and gravity. No, none of that. We throw all that in the trash can. It's got nothing to do with mass. It's got to do with the fact that all atoms are physically interconnected. They're connected to all other atoms, and that means that every atom in a star is connected to every atom, physically connected to every atom of every other star that forms the galaxy. That's why the stars don't fly out. And then the whole thing rotates like a carousel, and on top of that, you have the galactic magnetic field, which are the threads which are sweeping around the edges of the galaxy and up through the center, what they call jets. They think there's a black hole in the center of a galaxy, and they say, oh, the jets of the black hole. No, those are the threads of the magnetic threads which are sweeping around the galaxy, up through the center, down through the sides. Okay, and that helps maintain the integrity of the galaxy and make sure that no star flies away. Black hole, again, no such thing as a black hole, no such thing as dark matter, no such thing as Big Bang or wormholes or none of the nonsense created by mathematical physics. And we can explain why life cannot get out of the solar system. I've covered that in a couple of videos at least. So yeah, we cannot get out of the solar system. It's impossible for life to make it out of the solar system. And yeah, not going to go into that in any detail. But here's we have Richard Muller. He's a professor at Berkeley. I think he's still teaching, whatever he teaches. And he says something important. Here it is. There's the summary, and he vouches for the rope model. It says, every atom on Earth is pulling on every atom of you. You're also pulling on it. How do you pull without a mediator? See, these people talk about action at a distance. That's black magic. That's, witchcraft. Voodoo physics, as they call it. No. If one atom is pulling on another atom, there had better be an elongated mediator between them. And that's what the rope is. And he says, you're pulling on atoms right now on the other side of the Earth. The amazing thing about gravity is it goes right through things. Yeah, because all atoms are interconnected. So whether one atom is behind another one, they're still connected to, that atom that is attached to it by a rope. Now we can explain gravity, we can explain light, we can explain magnetism, electricity, and even the structure of the atom, what an atom actually looks like. No little bead, no little electron bead, which you got to find in a certain cloud, wave function, whatever they call it. Who cares about all that? That's nonsense. That's mathematical nonsense. Okay, so that's our model. Okay, here's light. You always wanted to know what light looks like. That's what light looks like, the mediator of light. It's a torsion, okay? So you have this situation, it's torquing. That's why it's so fast. And you can see when you torque it, the links become shorter and you have more links. And when you untorque it, suddenly you have your frequency went down and your wavelength increases. We're done. That's why light is a constant, travels at a constant speed. In fact, the speed of light is a measure of the tension on the rope. That's why it's 300,000 kilometers per second. Okay, so what does Leo say? Well, again, he starts his presentation by saying that he's an ignoramus. I'm not saying this. He's saying that, okay? He's saying that he doesn't know nothing. After 50 years, what has he contributed to science, to physics? And the answer is he hasn't contributed anything. But you have contributed to his salary and to his well being through your taxes, right? And so, yeah, I think I have a little bit of problem with that. And so, listen to him. Don't listen to me, okay? Listen to him. He's going to tell it to you in his own words, okay? Okay, so here it goes. Listen to him.
I have spent decades thinking about light. Decades. And after nearly 100 years of quantum mechanics, we still don't fully understand what it means. Even Maxwell didn't fully understand what was going on. Light is weird, and after 50 years of studying it, I can tell you that we still don't fully understand it.
Okay, so again, you take his class, you say, I'm going to take class at Stanford University, big name university, you know, and I'm going to take it with one of the head honchos. He's considered one of the greatest mathematicians alive, maybe of forever, you know, in all times, together with Ed Witten and other nimwits. Okay, so nitwits, and so what does he teach? What can he teach if he says, "Look, I don't know what light is." After 50 years, he still doesn't know, and we learned that on our first day of class. You know, it's kindergarten stuff. It's a rope. That's what it is. He's still working with these ancient particles and waves, transverse waves. He calls them wave packets because, you know, they have behave a little bit like particles, a little bit like waves. He doesn't know why. Yeah, only a rope can do that. Can simulate both, you know, particle at the endpoints, right, and in between it travels, meaning it doesn't, right? It torques like a wave. That's how simple it is, and that's why it's so fast. Anyways, he goes in there. Then he goes with the next step. He says, "Oh, you thought you knew what light is, right? You thought it was a particle. You thought it was a wave, right? Or maybe a wave packet. Well, you're wrong. Okay, you're wrong. Where did you get that? You got that what from? An ignoramus like Niels Bohr or Heisenberg or one of those guys?" And then the next thing he says is, "By the way, you know, light is a particle, light is a wave." So first he denies it, and then he confirms it. Those are the kind of classes that he probably gives at Stanford. Listen to him. Don't listen to me. Okay, I'm just putting out here what he says in class. Here it is. These are his dissertations. Listen.
What do you think light is? You probably said something like, light is energy that travels from one place to another. Or maybe light is tiny particles flying through space really, really fast. Or maybe you're a little more sophisticated and you said light is an electromagnetic wave rippling through the vacuum. Here's the thing. Every single one of those answers is wrong. Light is electromagnetic radiation. It's made up of photons. It has both wave properties and particle properties. It's one of those things that every physics student learns about.
So, is light a wave? Is it a particle? Is it both? And he says, if you said any of those, you're wrong. And then he says, yeah, that's what they are, the particles and waves. And so that's how he gives his classes to his new students. And they repeat this to the next generation, and they keep repeating this from decade to decade. And that's where we're at today. These people just learn nonsense about waves and particles. They say it ain't, but then it is. So I don't know what you learned in those in at Stanford. Is this what they learn at Stanford? Okay, so here he says something that shocked me, which was the reason I looked at his video. And it's he says that light doesn't move. And I said, well, how does he explain that? Let's see how he's going to explain it. Listen to him. Okay, here it is.
The photon that left the surface of the sun 8 minutes ago, from its own perspective, arrived at your eye at exactly the same moment it was emitted. No time passed. No journey occurred. The emission and the absorption are the same event. The sun and your eye are, from the photon's perspective, the same place at the same time. Lenny, that's crazy. That doesn't make sense. And you're right, it doesn't make sense.
Yeah, it doesn't make sense. None of quantum mechanics makes sense, but they continue on, as if nothing. They're bumbling fools. That's what they are. They say it doesn't make sense. Particle can be at two places at once. For the photon, it's the same thing being at the sun as in your eye. They say stupid things like that, and they just continue as if nothing. So what are you supposed to understand from what these people teach? What do they know? Why are you paying their salaries? That's the question. You have an ignoramus that's teaching your sons, maybe you, if you're young enough, right? Okay, and then after he says that, the photon doesn't move because it's still there, and again, all they needed to do is define the word motion so that we know what motion is, and then if the photon matches the definition of the word motion, then it's moving whether the photon likes it or not. And so they have this, what the photon doesn't sense that it's moving. This is stupid. This is like saying, your family goes to say goodbye to you and you board the train and you watch them through the window and you're sitting down, right? So you're not moving, right? But they see the train moving, they see you go away, they say, he's moving. And you say, well, I'm not moving because I'm standing still or I'm sitting. I'm not moving. This is what they're saying, that the photon is not moving because it looks at itself and says, well, I'm not moving because I don't experience time. I don't have a watch. So they interview the photon, are you moving? No, I'm not because I don't have a watch. Oh, okay, great. Okay, and then he goes in there and says, but it does move. Okay, here it is. Listen to him. Okay.
When light enters, say, a piece of glass, the photons interact with the atoms in the glass. They get absorbed by the electrons in those atoms, and then almost instantaneously, the atoms re-emit new photons. These new photons travel at sea between atoms, but there's a tiny delay, a tiny pause between absorption and re-emission. And it's these tiny delays, accumulated over billions of interactions, that make light appear to slow down. So the light isn't actually moving slower. The individual photons are still zipping along at 300,000 kilometers per second between each atom. But the overall propagation of the light signal is slower because of all those little...
You can only explain that with rope. There's no other way. You cannot explain that with little beads, or waves, one-way waves. But see, he's saying that the atom absorbs the wave or the photon, whatever, right? No, it's not absorbing. What you have is a permanent connection there. And between every two atoms, the rope is always traveling in other words, torquing at 300,000 kilometers per second. That's the speed at which the signal, the disturbance travels along the rope. And so we have to make sure that we understand that you can only explain that with a rope. And let me tell you why. When it comes in, it goes at 300,000 kilometers per second, right? And so it's bouncing around. It's the whole light, the whole beam of light is slowed down in glass. Like, glass is... we use a refractive index of 1.45 in the industry, in the semiconductor industry, but let's go round off to 1.5. That means that light travels at 300,000 kilometers per second in the vacuum, it travels at 200,000 kilometers per second through glass, right? What makes that beam go back to 300,000 kilometers per second once it leaves the glass? What speeds it up? And yeah, they had to say that between every atom, between any two atoms, the speed is always the same. But the overall beam goes slower in glass. What makes the whole thing go faster later on? Aren't there any interactions with the air molecules that, or with whatever's out there in the vacuum, right? Whatever few atoms there are out there. So we have a problem because you need to explain why light speeds up again to 300,000. Why doesn't it continue going at 200,000 like through glass? You know, there are atoms outside, the glass as well, air molecules, for example. Okay, so one thing is good about this. He starts saying that the atoms are actually connected. He uses that word connected. So listen to him. This is important because now we're going to educate him on the rope model. Okay, and here it is. Listen to him.
Light comes in discrete packets of energy called quanta. These quanta are what we now call photons. Light behaves like a wave in some experiments and like a particle in others. How could it be both? The answer that quantum mechanics eventually gave us is both profound and deeply unsatisfying. Light is neither a wave nor a particle. It's something else entirely, something for which we don't have a good word in everyday language. It's a quantum object, and quantum objects don't behave like anything in our everyday experience.
So yeah, you can only explain light if you use an elongated object mediator agent, such as a rope. Then you can explain it. And it turns out that, we have Leo, and he's going to become my biggest fan now because he's going to say, look, it looks like Bill was right. We have some kind of connection there. Listen to him, and he's going to give you the punchline. The punchline is that Leo is now my fan, okay? Listen to him.
Light doesn't move. It connects points in space-time, but it doesn't experience the journey between them. It's more like a bridge than a vehicle. A bridge between distant stars and your own eyes, not a wave, not a particle, not an electromagnetic disturbance. It's a connection. A thread woven into the fabric of space-time itself. It exists at both endpoints simultaneously. The journey is an illusion. The more we learn about light, the more connected everything becomes. Light is the glue that holds our universe together. It simply is existing at both endpoints simultaneously.
So yeah, he's my biggest fan now. He's, I guess, coming around and understanding finally that yeah, it is a connection. That's what it is. That's what light is. It doesn't go anywhere in that sense. He's right. It doesn't move. It just torques in situ. And so yeah, once you become familiarized with the rope model, you laugh at everything that quantum mechanics came up with in the last 100 years. You throw it all in a trash can, and general relativity together with it, and string theory, the whole shebang goes down the drain. So yeah, there we have it, folks. We're trying to educate the mathematicians. They refuse to be educated. They want to continue with waves and particles, and then they say, we don't. We can't find any meaning. Yeah, no kidding. Okay, I'm going to talk about another subject now. I think it's important. Fellow the other day, at the end of my presentation, he started asking a couple questions, and I thought I'd address that a little in a little more detail. This is what he said. He was talking about. He said, "Can I ask you a question?" He said, "Yeah, go ahead." And this is how he started. He says, "What's the substance in the volume bulk of the rope? What do you call it, and what are its properties?" He's trying to ask me what substance is the rope made out of, right? And I said the rope is made out of two threads. You know, I always give the same answer because people are asking the wrong question. They want to know what the ultimate material is, essentially, right? Okay, so he's saying, I'm not talking about objects making up objects, like, in the case of mereology, right, where objects are made out of objects, or you have parts of whole, that's what they talk about in mereology. And I'm saying, I'm not talking about objects making up objects. I'm talking about what filling of a rope or thread. Filling, I say the blue part is my answers to him, right? A thread is made of single piece. It's not made of parts. The thread is a primitive, the elementary substance or fundamental substance, you can call it, right? Fundamental entity. He said parts are objects. Substance is filling. So I don't know. He thinks that substance is different than object. No, they're synonyms in physics. And this was hard for him to understand. He kept saying that substance is something different than objects. So what is substance, and he could not give me an answer. I asked him if he could define, what a substance is, especially to distinguish it from an object. And he never came back with that. He just kept saying, what is the substance of the rope? And essentially what he was saying, is that a rope is made out of other objects, out of things. And especially the thread. The thread is made out of other things. And I'm saying, no, the thread is made of a single piece. It's the ultimate substance, the ultimate thing that makes up everything else. And so I asked him to define object and substance, and he kept skirting the question. He never answered that question. Here, see if I can. He says substance is the plastic making up the bag. Yeah, but you have to define what you mean by substance. I don't know what you mean by substance. If you're saying that it's not an object, then I need that definition. And he never did. He thought that shape required a filling. That you have this thing on the inside of the shape, and the thing on the outside of the shape. The one on the outside, we can call it space. It gives it a contrast, a background. And then he says, you need the inside also. You need a substance on the inside of shape. And no, we don't. So that's essentially what I'm trying to say here. We're saying that in the case of the thread, it's made out of a single piece. It's not made of little parts that make up the little thread. Okay, the ultimate thing is, a single thread. That's what makes up all the matter in the universe. And he was trying to find out, what it's made out of essentially, and what is the problem there? The problem is there that quantum mechanics has. It's a fatal flaw. You ask, is the electron the ultimate particle? And they say, yeah, it's an elementary or fundamental particle or entity. And you say, what is it made out of? Wrong question, because he's already telling you that it's a fundamental particle. And the way they answer, they don't say it's a wrong question. It's an irrational question because it's the fundamental one. It's a fundamental object, a fundamental thing that makes up everything else. That's not how they see it. They see it in something totally different, which is the irrationality of mathematical physics, which is, let's run an experiment, let's smash it, let's find out what particles we get out of that, and then we'll give those a name, right? We'll just use more energy to smash two electrons together. Maybe we need an accelerator as big as the solar system to do that. And so, okay, so the electrons made out of Johnnies. We'll call them Johnnies, right? So now we have the electrons are made out of Johnnies because we smashed them, and now they're little particles. Now no longer is the electron a fundamental or elementary particle. Now it's made out of Johnnies, okay? And you say, well, what is the Johnny made out of? And you say, well, give me more money. I'll build a an accelerator as big as the galaxy now, smash those Johnnies, and we'll find out what they're made out of. And so we build one, build an accelerator as big as the galaxy. We smash the Johnnies together, and now you say, well, what did you find? Well, I found they're made out of Tommies. We call them Tommies now. And then the next question is, well, what are Tommies made out of? And so quantum mechanics, instead of answering the question, having definitions and say, look, there's a fundamental particle that makes up all of the particles in the universe, that's not what they mean by the word fundamental or the word elementary when they say elementary particle. What they mean is, for now, it's an elementary particle because we cannot determine through an experiment what it's made out of. That's the answer. That's not the case in the rope model. The rope model, yes, we do have a fundamental entity, and the buck stops there. It's known as the thread, the single thread. That's the ultimate thing, and it's not made out of anything. There's no mereology there. Okay, the thread is not made of anything else. It is rational because now the buck stops there. We don't continue in saying, well, what is the thread made of? Well, it's made out of Johnnies. What are the Johnnies made out of? They're made out of Tommies and so on. No. It stops at the thread. The thread makes up everything else. Okay, and that's rational. What's irrational is what quantum mechanics says. They say it's an elementary particle, and you say, well, what is it made out of? Well, give me more money. I'll build a collider that's big enough to smash them, and I'll tell you what it's made out of. And they just keep giving names to the new particles, the new lines they see on the, in the chamber in there. Okay, so there are two problems with this fellow saying. One is that definitions. The other one is mereology, parts of whole. Parts of whole, mereology is religion. It's got nothing to do with science or philosophy or anything. It's just nonsense, pure nonsense. What things are made out of, that's got nothing to do with anything really. But that's how the so-called philosophers came up with this nonsense called mereology, a branch of that an object is that which is made of more objects. What is the thing? The thing is that which is made out of, it's anything made out of things. That's the way you see it. So one of the issues is, definitions. And we had to, produce these words. You cannot do physics without any of these words. You cannot give a physical interpretation without these words. You need to define these words. And so, when we compel people who ask questions to define words, they say, well, I didn't come here to do semantics and word salad. I came here to learn about physics. And we cannot communicate physics unless you know these words. You can define these words. If you have a different notion that we have here of these words, then we have a problem. We have a communication problem, right? And so, we have defined these words. There you see the definitions that we have for these words, okay? And if you don't like them, if you have some other definition, you have a better mousetrap, hey, we'd like to hear it, And so these are all related in the sense that, one relies upon the other. We have object, and that is that which has shape, and then you see concept at the bottom, and it requires two objects. So you need to define the word object before you define the word concept. And you need to distinguish between objects and concepts because the mathematicians are moving mathematical concepts around, and they can't do that. We don't move concepts in physics. That's the problem. They move vectors, they move fields, they move the force, they carry the force, they carry the interaction. Those are irrational terms. You can't talk like that in physics. So the mathematicians have developed an irrational language. Has no place in science, let alone in physics. Okay, so you need to define these words. And so when we require that people define these words, they run away. They say, oh, Bill, you're doing a semantic argument, word salad. I came here to do physics. You can't do physics without those words. And so, here are some words from the mathematical dictionary, okay? What is a black hole? Well, that's a kilograms. That's what it is, in zero volume. That's what a black hole is. They crunched all this matter. They made up a star to the point where it occupies zero volume. And they say, well, that's infinity. And that's why we call it a singularity. That's where the laws of physics break down. And that's when they abandon the podium. They stop talking at the microphone. They say, we've explained it. We call it a black hole. Dark matter, it's a virtual particle. That's what you got to look at. What's virtual particle? Way at the bottom. a value that magically appears from the void to make the equations come out right. And that's exactly what dark matter is, just a variable in an equation. They had to put that in there. It's called mass. They just put more kilograms in there to make the thing come out right so that it matches what they observe, invisible matter. Electron, that's the weirdest one. Probability of finding an electron in a cloud known as a wave function. That's what it is. That's what an electron is. It's electron is finding an electron. That's what it is. Where it's at. What is the probability of finding it in a certain region? And you have all these words. You have exist, which belongs exclusively to physics. They say, well, it's that which is real. You look up real down at the bottom there, somewhere, real, that which exists. So we have exist is equal to real, and real is equal to exist. That's what you'll find. And so on and so forth. So the dictionary of mathematical physics is completely screwed up. You cannot make any sense of anything there because they never realize that how important it is to define words. And especially that word thing out there, the word object. I did it with thing there because it's better than anything made of things. And that's what a thing is. And that's what Mariology is all about. What is it made out of? And this is irrational. That's not what an object is. They say it's, made out of matter. And what is matter? Matter is a bunch of objects. And so what you're saying is an object is that which is made out of a bunch of objects. That's the definition that they're working with. And again, you have to define these terms precisely if you're going to communicate, your theories. And these people don't. And here are the definitions you find in the Wikipedia and the dictionary. An object is an identifiable what? Collection of matter. What is matter? A bunch of objects. And so you have objects, a bunch of objects. That's the definition they have in the Wikipedia. What do they have in the dictionary? Anything. Already failed there. The word anything. Anything is what we're trying to define. But they say an object is anything. A thing is anything, right? That is visible or tangible. Absolutely not. Not all things are visible or tangible. Especially the table I've got in my head, the one I'm thinking about, the one I'm visualizing, you can't see or touch it. Believe me, I can barely see or touch it. I can't touch it for sure. Can I see it? Well, maybe. If I close my eyes, maybe I can see it in my mind. But certainly I can't touch it. So, see, touch is the wrong criteria to define objects. And here we have the definition of an electron, and this is out of the AI. And you can see how screwed up it is. An electron is not a tiny solid ball. Okay. What is it? Well, it behaves. They immediately go into behavior. I don't want you to talk to me about behavior until you tell me what thing is behaving. First, you got to tell me what an electron is. Then you can talk about behavior. And so they say it behaves like particles and waves. And so that doesn't tell me anything because I still don't know what an electron is. Is it a particle? Is it a wave? I mean, the fact that you're saying that it behaves like that doesn't tell me anything. Has no internal structure, has no measurable surface. So it's not a thing, apparently, right? It does not orbit the nucleus, right? It exists in a probability cloud, whatever that is, a cloud of probability, a wave function, right? What that means, I don't know. How can it exist? It lives in a cloud of probability. I mean, what does this cloud rain? Numbers? Cloud of numbers, and it's raining numbers now, 5s and 6s on your head. Okay, it is a 3D region of space where the electron is likely to be found. So electron is where an electron is likely to be found. That's what they're saying. And an electron is actually a ripple or vibration in the electron field. What is a field? A value at each point in space. So you have all this contradiction, and then finally they say, well, it's a quantum object. What is that? Well, it can be at two places at once. It when it's doing the slit experiment, it's at both slits. It affects the other electron with nothing in between. It does it by remote control, telekinesis or whatever. So they have all this nonsense. They have no explanations for absolutely anything after 100 years of quantum. So what's the point of going to like Stanford University and taking a course with good old Leo, Susskind, if what's he going to teach you? He's going to teach you this nonsense? What are you going to learn? And he said, well, we do math. Or like Niels Bohr said, shut up and calculate. Okay, so here we have, this is where the problem is. That was the definitions part. Here you see the definitions of mereology. And it says a branch of metaphysics. Metaphysics? What the hell is metaphysics? That studies part-whole relationships. And again, that's pure nonsense. What is that? Table has four legs. So is that what a table is? A four-legged, one-board thingy? Is that what they're saying here? Or you have the time version, which is, you come in, you see the table from one end to the other through time, so you see it in pieces. So it's parts of time. Metaphysics, the branch of philosophy. Philosophy? Uh-huh. That examines the basic structure of reality. No, absolutely not. The only discipline that deals with reality is known as physics. Reality, existence, belongs exclusively to physics. Anyone dealing with the word exist or real or reality has, whether they know it or not, they've crossed the line into physics, because that word belongs exclusively to physics. Physics is the science of existence. And it says philosophy. What is philosophy? Love of wisdom. Nobody ever defined the word philosophy. The study of questions concerning what? Topics like existence, knowledge. No, absolutely not. Existence belongs exclusively to physics. It has nothing to do with philosophy. Okay, so these people started off on the wrong foot, the Greeks, and everybody just followed through when that's not the case. Philosophy has nothing to do with existence. That's why you need to define these words. What is philosophy? What is physics? These people don't even know what the subject matter of those disciplines are. And in reality, the state of everything that exists. What does exist? The state of being real or reality. I love that. And what is everything? Everything that exists. Yeah. Okay, great. So, you don't learn anything with these definitions. These are taken out of, the Wikipedia primarily, right? And then they have the problem of universals. What is that about? Well, should the properties of an object be considered to exist? The properties exist? No, properties cannot exist. First, you have to define the word exist in order to talk about whether concepts can exist. And the answer is no, because the word exist belongs exclusively to physics. Physics deals with objects, not with concepts, okay? So you can't say that a concept exists. It's irrational to say that. And then here you have ontology, another branch of so-called philosophy, subdisciplinary branch of philosophy of metaphysics that studies what? Being. What is being? Maybe they misspelled it. Maybe they're talking about beans, that you eat. Focuses on the most general feature of what? Reality. Again, they put reality into philosophy, into ontology, into metaphysics. Reality has nothing to do with any of that. Reality belongs exclusively to physics. It's a physicist who has to tell you what reality is all about, what exists. Okay, and then he's got to tell you how it works, right? Epistemology, the theory of knowledge. What is knowledge? We don't know. An awareness of facts, whatever that means. Okay? Knowledge of fact is often characterized as true belief. Yeah, justified true belief, right? And what is truth? Conformity to the reality of fact. So it takes you right back. What is fact? A true datum. And what is data? A collection of values that convey information describing the quantity, quality of what? Facts. So you can see these people have circular definitions, meaning they use synonyms to define. You can't use that in science. You have to use other words that are not synonyms to define a word, and they don't do that. And so they keep going around in circles. They've been doing that for at least 2,500 years since the Greeks, people like Plato and Aristotle and so on. And so they don't have solid definitions even to this day. And not a single philosopher, so-called philosopher, since then has ever pinpointed the definitions. And not to mention the physicists, the so-called physicists, the mathematical physicists. They don't deal with words at all. They just go to the dictionary and borrow whatever word they see there. And they say, here's the definition of object. Here's the definition of exist. Here's the definition of distance or whatever. And they just pull it out of the dictionary without ever analyzing whether it makes sense to bring that word into physics. So they're using words of ordinary speech, and they're bringing them into the scientific environment indiscriminately without, even analyzing or criticizing it or coming up with a better mousetrap, better definition. That's where we're at today. That's why nobody can understand anything in mathematical physics, because they never defined the language needed to convey theories, mechanisms, causes. That's a wrap, and I'll see you next week.